All right, I'm going to get started. Ready to go? Okay, so uh, my talk today is on extending the CMC with metacognition. This is the common model of cognition. As I said, it was originally called the standard model of the mind. The goal is to have a consensus abstract model of cognition, of cognitive architectures for human-like behavior. So it is not about neurons, but we would hope that it is consistent with brain structures, and some of the work that Andrea has done over the years has showed that at some levels it is very consistent with that. So there's it's a pretty simple model. As you can see, there's multiple modules, and the modules have connections. And the fact that there's some connections and not all connections is very important. So the reasoning cycle is driven by the connection between procedural long-term memory and working memory, but all the other components are critical. And the focus of it is on routine performance and learning as opposed to metacognition. So what about metacognition? And I think this is maybe the most controversial slide of the whole talk, which is where I try to frame what each of these are. So I'm going to claim that metacognition is cognition about cognition, or reasoning about cognition and all of cognition. So when you're thinking about how can I learn better, that's metacognition. When you're thinking about how should I study for a test so that I'm going to perform better on the test, that's metacognition. How should I maybe learn to look around the world in order to be more efficient? That's metacognition. And when I think about how I maybe try to learn how to learn better, that is all metacognition. So that is pretty broad. We're going to focus a lot of the talk on meta-reasoning. So what's the distinction here? Is it's reasoning about reasoning. So it's not reasoning. I'm going to exclude things like reasoning about perception or reasoning about learning for the short term of this discussion. So it's just reasoning, and obviously in terms of the CMC, it's going to be mostly reasoning about the cycle that goes on moment to moment in terms of its reasoning. So reasoning is what's for the CMC. Meta-reasoning is reasoning about what happens in the reasoning cycle. And I should now say a little disclaimer: these are my thoughts informed by discussions with others, and there might be disagreements on specific points of any of this with my collaborators, but this is my current view on it. So the question is, how can we extend the CMC to include meta-reasoning? And we take inspiration from CMC architectures such as Soar, Sigma, and ACT-R. So there's a lot of examples of meta-reasoning: introspective monitoring, where you're trying to be sensitive to the fact that maybe you hit a failure in your processing and you want to recover from it. That's sort of the second one as well. Retrospective reasoning, I think, is a classic one where you've tried to solve a problem, you haven't been able to, or you have been able to, and then you go back and say, now, why did that work or not work? And you try to reconstruct the reasoning that you did. So you're reasoning over your prior reasoning. So there's these alternative models of metacognition, and I'm going to talk about two of them. One of them I'm going to call there's a meta-reasoning module. So if we take this as the basis of reasoning or cognition, so this is an abstract view, you have the environment, there's a situation representation that comes from perception and also from reasoning. Then the idea behind an additional module, which is true of a system called Midka and others, is that you consider this as a thing that is going to be studied. And so you create something on top of it that has better reasoning knowledge that reasons about this. So this is the subject of reasoning. And you have access to this in some way. Exactly what access you have depends on specific architectures, but you might have access to the representation of a plan, or the decisions that you made in the past, or even the knowledge you're using to make decisions and the situation. So that is and so the unified model is where we have reasoning over our situation, and meta-reasoning means we don't change things that much. We sort of bulk everybody up, and now we include in the current situation some aspects of the partial reasoning state. Okay, so that is now available to be reasoned over, and the magic question is going to be what is that? And we also then assume that we're increasing the knowledge here so that it has reasoning. And we'll talk more, the whole talk, a lot of the talk is about what that unified model is going to be. So the merits of the meta-reasoning module approach is that there's this clear separation between reasoning and meta-reasoning. And it allows for continual processing. So you can be reasoning and doing meta-reasoning at the same time. And so you can have, pretty deliberate thinking about your thinking, monitoring and things like that. And you don't get interference between the two. And you can really focus on what goes into domain-independent meta-reasoning. Some of the challenges are it does require a more complex architecture. There's limited reuse because you have all this knowledge down here, and some of this knowledge might really be useful in order to do meta-reasoning. And you don't have it directly up there, you have to sort of interpret it. And also it assumes access to these modules internals, which might be incompatible with neural models of memory. So you actually can look inside and see what structures are. So on the unified side, the merits are sort of complementary, a simpler architecture. We can reuse anything we knew about doing a problem and just behavior in general. We can now use that for doing reasoning, and it leads easily to reflective sort of recursive meta-reasoning. It allows for very fine-grained intermixing of reasoning and meta-reasoning. So you can be reasoning for a few steps and then go meta-reasoning for just a little bit and then go back to reasoning. And also you seem to think, I would seem to think this is compatible with neural models of memory because we don't require anything to look inside the memories themselves. The challenges, we don't have parallelism. There's no pre-existing self-model to access. So in the other scheme, there was this whole system up here you could access, and you sort of had a model of yourself that you could access. Here, we're going to have to build that up. It must learn incrementally from indirect and direct sources. And there's a question of what's the source of the reasoning state. So keep that question in mind. All right, so here's the CMC architecture. I'm going to start with how we can make modifications to it to get direct access, direct sources of knowledge about reasoning. Now, you're going to all be disappointed in what those sources are, probably, because they're not going to be suddenly declarative memory comes into working memory or procedural memory comes into working memory. Instead, what we're going to do is we're focusing in on just we call them metacognitive appraisals, things we know about the processing in each one. So I call that, what we're going to do is we're going to add to the buffers that are already there, we're going to add what we call process state buffers. So in each of these little buffers that I've added, we're going to get state information about the processing that's going on in this module. So that's like, were we successful in trying to retrieve something from semantic memory? Did we fail? Did we get something close? Are we confident in what we got back? So it's state information about the processing in that module. And we're going to go through these one after other. The other big change is we're committing to a split between semantic memory and episodic memory. And it's not so much that there has to be a split. There has to be both functionalities. So there might be still just one memory, but we're committing to the fact that we do have episodic memory available to us. And after today's morning's talk, I feel pretty confident that that's not an unreasonable commitment to make. All right, so the key thing with episodic memory is it's going to be recording in some ways the history of the processing of the results or what's going on in working memory. Okay, that's what's going to be there. And it will include those state buffers. All right, so let's go through just one at a time, some examples. So in terms of what would come back from the procedural memory in terms of process state information would be things like, I can't make a decision. I've made it, either because I've got options that I can't tell the difference between, I have conflicting information, and some people in the room might map that onto some impasses and Soar. And that's what I do. For semantic memory, it would be information about why I couldn't retrieve something from semantic memory, possibly how confident I am in something that I retrieved from semantic memory, or other, what you might call metadata about the retrieval. In episodic memory, it's going to be, once again, very similar. Could I not retrieve something Did I get a partial match and things like that? From perception, it could be I couldn't identify this part of the scene. I'm very confident in my identification. I'm unsure about this, things like that. And motor, it might just be feedback that I tried to do this command and failed. The other thing that we have here, which is a little uncertain, but we think is important, is information about the processing or the operation of working memory. Did things happen in working memory that were unexpected, such as a surprising thing occurred in working memory? So that sort of maybe maps onto some kinds of appraisals. But the point is that now all this information is available in working memory for the system to reason over. So it's not got just the task information, but it's got information about its own processing. And so my claim is that makes it meta reasonable. So those were direct sources of information that are made available, but there's also indirect sources of information that can become available to an agent for it doing its reasoning. So procedural memory, it might get something back that it has learned from others ways, and it can also compile meta reasoning into reasoning. Semantic memory saves information that has been in working memory. Episodic memory, and then things from the environment. I can observe myself in the world and learn about what capabilities I have by watching what I do and what I don't do. I can have other agents tell me, you're really bad at math, or something like that. So I then help create a self-model of my reasoning. And I also can keep a diary, and then I could go back and read my diary and say, oh, that's what I thought about this. And so that becomes my reasoning. Also, the very act of doing meta reasoning is going to combine information from all these sources, indirect and direct, to produce more information, which will then, of course, be saved in the other memory. So meta reasoning is another way of getting indirect information. All right, so these are types of information and where you might get that knowledge, either direct or indirect, in order to do it. And if this was an hour-long talk, maybe I would be able to give examples of each of these, but that's not going to happen. So this is just to give you a teaser to say, here's how we think this model of meta reasoning can work here. And what's missing, but in Soar, is that there's explicit representations of operators in Soar, so it actually knows what it's thinking of possibly doing. And those are called acceptable preferences. And I'm going to claim that when we have reasoning about preferences, we're actually doing micro meta reasoning. We're saying, here's what our options are, and here's the best thing to do. And that's actually a little bit of meta reasoning. We don't know if that's it. It seems important in Soar to support perspective and hypothetical reasoning. Don't know if it's a requirement. The other thing Soar has is when it hits an impasse, it creates a subset, which lets it have substate, which lets it have a separate place to reason about what it was reasoning about. And in Soar, that's really critical. Can you get by without it? Don't know. Don't want to propose it right now, but it seems like that might be something. The last thing is, so should these be part of a proposal? I'm not saying they should be, but I'm saying that they should be considered. And the last one is, do LLMs have metacognition and meta reasoning? So under this model, they only have indirect sources of knowledge about reasoning. They have things they've been trained on, but they don't have access to their certainty of, usually they don't make access explicit to like the certainty of conclusions and stuff like that they reason over. They definitely don't have episodic memory. And so I'm going to claim that they can reason about what they've been trained to reason, but they cannot reason directly about their own reasoning. And if that doesn't get you confused, okay. So that's it. Any questions? Got time for a few questions? James.
They reason about their own reasoning if you put that reasoning into their context and then it's them to.
But they don't do that, right? So there has to be something externally that is recording their reasoning, but they don't even have their reasoning. What they have, yes, it's up in the air whether what you have is reasoning or just steps in their. So there's that potential.
Right. Like I can take their like chain of thought phrase.
Yes.
And then have that as first input.
Yes. Yes. James?
I was going to also mention chain of thought.
Yeah. All right. Andrea.
That was awesome. What would a state buffer look like in an LLM?
It would be that prediction I just made about the next token.
Mm-hmm.
Okay, I actually had 3 different options there, and this was the best one that I had. I mean, it's not a lot, but it's something. And the fact that they don't have the other modules really restricts them to what kind of knowledge they have about their own reasoning. And we're
Yeah,
gonna have.
I was thinking about that. This is a part where having an architecture that has explicitly different modules helps.
Right, so when we have more ones with multiple modules, they might have that possibility. Paul, I'm sorry, gotta move on to the next talk. And the next